Divide by 9 to show an algebraic approach. X equals 2. So are we done with just saying 2? What are we saying? 2 different drinks were offered. Sentence. Yeah, not 6. Let me check. The next one says a multiple choice test has 10 questions with 4 answers each. So how many questions are on this test? How many blanks will we have? 10. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many options do you have for the first one? 4 then. Make sure you have the dots for multiplication. 4, and you put the dots up, not in between the lines. In between the numbers. So it's the same as 4 to the, bless you, 10, which is large number. $1,048,576. Remember, if it's a written response, you have to have a sentence. So how many ways can you complete the test? You can complete the test in 1,048,576 different ways. If you think on a 10-question quiz you're guessing correctly, you have a 1 in 1,048,576 chance of getting 100% by sheer guess. Sheer guessing, not any knowledge. All right. There you go, 4 and 5. Try them out. 10 different models of cars are parked side by side. The different models is very important. The different models is very important because it means that you can tell them apart. If you can't, you have to divide by factorial all the colors on the bottom because you'll be able to tell them apart. There's difference if you watch the same model or different. How many ways can you park so that the 5 blue cars are together? 2, 3, 4, 5, 6, 7, 8, 9, 10. Do you care what the rest are? No. I would care if they were the same model, because then I would have to know how many of each color you have. Because they're not divided by factorial, it doesn't matter. We have to keep the 5 blue together. So we hook the 5 blue together. We said there could be 5 here, then 4, then 3, then 2, then 1. Make sure you have the multiplication dots and make sure they're between the numbers, not between the lines on the bottom. If you're multiplying the numbers, you're not multiplying the lines. Then, how many cars do we have left? How many cars do we have left? 5, then 4, 3, 2, 1 times 6. Always one more than the hook together number because there's 6 spots so that those people can move right and get the same numbers in different cases. So it's a 5 factorial times 6 factorial answer, which is how much? All right. How many ways can they park so that the 2 yellow cars are not together? When you have not together, you have to be prepared for those. Those will happen on your test, the not together. You have to do total minus them together, and then what's left over is them not together, right? So total no restrictions minus the yellow cars together. And then what's left over are the yellows not together. Just like when I asked you how many people are not in this class, you didn't give me all the cases and go count all the people outside of here. You said, okay, I'll take the total number of people minus the ones in this class, and then what's left over the ones not in this class. So, how many total ways can I rearrange 10 cars? A lot. True. But how many ways is that? 10 factorial minus the yellow together. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 2 yellows, so 2 then 1, hook them together. How many cars do I have left? 8, 7, 6, 5, 4, 3, 2, 1 times what? 9. And then I'll just have what's left over. Anyone find it out? Right here. I believe in you. You guys should believe in yourself. Mainly give your answer. Oh my gosh. Everyone's typing it in because I'm typing it in, but I'm not giving the answer. Starts with a 2. $2,920,040. Okay. Using all the letters in the word sparkle, what's the first thing you do now when you get words? What should you always do? Rewrite them and see if there's any like numbers that repeat. Because if they repeat, you stack them, right? So sparkle, S-P-A-R-K-L-E. Did any double or triple? No, so I have no denominators. If they did, you have those denominators, right? That's the difference. You have like 2 easier divided by 2 factorial and 3 made 3 factorial. So the vowels of 3 together, there are 7 letters in sparkle. How many guys are vowels? 2. The E and the A. So I put them together. A different color. So I get 2, then 1. How many are left? 5, 4, 3, 2, 1 times 6. So you should get 1440. The next one says it can start with a consonant and end in a vowel. 1, 2, 3, 4, 5, 6, 7. Start with a consonant. How many consonants are there? How many vowels are there? So I fill those up first, right? How many letters have I used up? 2. How many are left? 5, 4, 3, 2, 1. So technically, if I take the 5 and the 2, that's 10. And then 5 or 3, 2, 1 is 5 factorial. So 1200. How do I know that? Because 5 factorial is 120 times 10. Okay. Next one I'm giving you is pool will. Words put together homework. I'm tripling it up. Be a pool will. People like cool. Awesome. I want it. How many ways can it start with the vowels? All the vowels. 2. Vowels together. 3. Vowels not together. We have pool will. The first thing you have to do is go P, O, O, L, W, I, L, L. I'm telling you, for those of you who are like, I'd like to save a little more pencil, and I'm not going to listen to you do that. You will get these wrong every time because you will forget to divide by the factorial. Okay? Not a time to save pencil. That's what I'm going to say. The reason why we write it out this way is so that we don't miss any doubling or tripling letters. And also when we write it out weird like this, we're like, why are we writing it out weird like this? Oh, because we have to divide by the factorial. Okay, so that's how we do it. It is 8 letters. 1, 2, 3, 4, 5, 6, 7, 8. On the bottom, every single time, this is going to have 2 factorial, 3 factorial. In brackets if you don't use the fraction button. Now, it says it has to start with the vowels. How many vowels are there? There are 3. Because we treat them like they're all different, right? Even though the 2 O's look the same. Because the 2 factorial and the 3 factorial get rid of the cakes where they're not. So we do 3, 2, 1, and then 5, 4, 3, 2, 1. Make sure you have the multiplication dot. Do I have to multiply by 6? No, because it says what? It says start, and that matters. If it doesn't say start, then I have to, which is what the next one does. So this is gonna be 60, I believe. Okay, this one is going to be 2 factorial, 3 factorial on the bottom. If you aren't getting that, you're getting a much larger number. Often it's because you're dividing by 2 factorial, 3 factorial without using the fraction button or not fractioning your denominator. Vowels are together, so I get 3, 2, 1. And then 5, 4, 3, 2, 1. But this time I have to multiply by 6. So I end up with 3 factorial, 6 factorial, over 2 factorial, 3 factorial. Now, why would I write it out this way? Because sometimes their answers are just in that fashion. And when they're multiplied by that, these can cancel off. So 360 and 720 divided by 2. Okay. The last one says the vowels can't be together. So if the vowels can't be together, then we do total minus vowels together. Well, total is 8 factorial, this is true, but it's divided by 2 factorial, 3 factorial. And then you minus the vowels together, which we already did, which is 360. It's from the previous example. Be 3,360 minus 360, which is 3,000. Here you go, back up. So here it says Julie's home is 3 blocks north and 5 blocks west of the school. North and west. So Julie's home is 3 blocks north. 1, 2, 3, and 5 blocks west. 1, 2, 3, 4, 5. Home. School. Does it say that she only walks north and west and then she's done, which is one pathway? And how many routes can Julie take from home to school if she travels either south or east? So she's traveling south or east to school. Now she has a few pathways she can do, so we're going to connect them. Here, here. Here she has all these blocks to go south, right? 3 blocks to go south. And then she has 1, 2, 3, 4, 5 to go east to the school, correct? Now the catch here is on a test they say to you that there's, and this one says she always travels south or east. And the reason why they have to say that is if not, you could loop. You could like infinitely walk around one block and never ever get there, right? You have to always go south or east. So please don't copy this down, just pay attention to text them. Make sure no phones are over anything. So I could go this way, this would be one path. Like I could just go, I could technically go east, south, east, south, east, south, east, east, and get there, correct? Or I could go like east, 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 south, south, south. Or I could go south, 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 east, 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 east. You know how to count those? Like you're gonna miss a few paths if you do it this way, right? I did 3 and I don't actually know what I just did. Okay? So there are ways that you can count the paths. I do not want you to write this. This would be for pathways, which we're not in. We're in terms of home. But I just want to show you that we get the same answer if we do it in a permutation way. Okay? So you're not writing down these numbers because you're never going to be asked to do it this way. I just want to prove a point. So technically, if I can only run east and south, there's one path to get me here. I could just walk to that cross section, right? And to get to this dot here, I could just walk to it. So that's one way to get me there, right? That's the only options I have because I'm not allowed to loop back, correct? Then I count my total path to go along. You do not do this. This is going to make sense to you. I just need to show you that what we're going to get is a total number of paths at the end, and it will match how we do it in permutation. Okay? Okay, so that's one pathway in. So that's one pathway into here, one pathway into here. So that's 2. And I can make one path to here, I can walk to it, one to here, one to here, one here, I can just walk to it. Or these south ones I can just walk to. So these are all one path as well. So I count the paths I go along. So this would be 2 paths in and 1 path in, so 3 total, 3 in, 1 in, 4 total, 4 in, 1 in, so 5, 5, 6, 1 is 6 paths. 1 and 2 is 3 paths, 3 packs coming in, 3 is 6, 6 and 4 is 10 total, 10 and 5 is 15 total, 15 and 6 is 21 total. 4, 10, 20, 35, 56. So this is what I needed you to see. There are 56 different paths that I could get going from home to school on either south or east, okay? Because I told them up and down along, which is not how we're going to do it. What we're going to do is we're going to count how many south and east we have, correct? So we technically have 1, 2, 3 souths, right? This would be a south, south, south. We have a south, south, south. If south, south, south confuses you, it wouldn't matter if you go downwards or over. It matters if you just go one direction. So I could say down, down, down. We can all agree those are downs, right? And then these would be right, 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 right. So in order to get to that school, I have to take 3 downs somehow and 5 rights. Do you agree? 3 downs and 5 rights in some certain different orders will get me to the school, right? Like I showed you, I could go down, 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 and then right, 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 all together and get there. Or I could go right, down, right, down, right, down, right, right. Correct? So to get from home to the school, no matter what, I have to do 3 downs and 5 rights. In different orders, it doesn't matter, but 3 downs and 5 rights. Correct? Like I could go right, down, 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 right, 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 right. So I still did 1 right, 3 downs, 4 rights, is still 5 rights and 3 downs. Do you agree? No matter what? So why can't I look at that as a permutation question? So I can say, okay, well, I have down, 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 right, 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 right. And I treat it like the word der. Very fancy word. It is der. Now, if I take that word, how many ways can I arrange it to get how many different words out of it? Well, how many letters are there? 8. So I have 1, 2, 3, 4, 5, 6, 7, 8, 20 on the top, right? I was doing the word. How many letters would I have for this one? 8, then. So that's technically just 8 factorial. Do you agree? Okay, what would I have on the bottom? 3 factorial on it? 5 factorial. Type in your calculator. Type this in. Everyone's typing it in, and you have a calculator you think you're running for, use it. Everyone get 56, the same number I have? I'm moving it. I'm moving it for you. All the other guys, you can say it means 120. All right. Got it. So it still ends up being 56. Do you agree? Because all we can do is do certain rights and certain lefts. Oh, wait, here's another one. So here it says, a supervisor of the city bus department is determining how many routes there are from the bus station to the concert hall, determine the number of routes possible. If the bus must always move closer to the concert hall. So we're moving from bus to concert hall. So can we not just treat this top square, like rectangle by itself and this bottom rectangle by itself? And then I need to do what to both of them? This is a hint. Times, multiply. Because you need these paths and these ones to get into the concert hall, right? You can't just do these ones and then fly through time to get to the concert hall. So this particular word would be down, 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 and right, right, right. So I can find that verb, and then times by this verb. Yeah. Do those 2 words separately. Try it out. 350. I need to in the workbook. Numbers 1, 2, 7. Maybe 1 to 6 actually. No, 1 to 5, 7, 9 to 10.